Hi there, this is Mr. Z from Zombe Tutorials with a quick video on how you can maximize your performance in the upcoming exam. Today we're going to be talking about the nature of the roots of a quadratic expression. The nature of x is determined by the value of this particular expression within the square root bracket. If this, which we call the determinant, is greater than 0, so b squared minus 4ac is what we call the determinant or the discriminant. It determines the behavior or what x will be. So if our determinant is less than, if it is actually less than 0, that means it is negative. So we cannot get the square root of a negative number. It will be imaginary, it will be non-real. So our roots will be non-real because we cannot get the square root of a negative number. And now, the next condition that we can get is if this determinant is equal to 0. Now, if our determinant is equal to 0, that means if we were to simplify this expression, if we were to simplify this quadratic expression, we're going to get x is equals to minus b plus or minus square root of 0 over 2a. And what we will get will be minus b plus the square root of 0, which is 0 all over 2a, or minus b minus 0 over 2a. And this will give us minus b over 2a or minus b over 2a. So if we simplify this expression, when our discriminant is equal to 0, what we will get are equal roots. Our roots are equal. And they're not only equal, they are rational and real. I think it's important we just explain the concept of rational. When we say rational, we mean it can be written as a fraction. It's a number, a value that can be written as a fraction, where both a and b are integers. Then we'll have our next condition. Our next condition is when our determinant is what? Is greater than 0. Okay? But equal to a perfect square, but equal to a what? To a square. When I talk of squares, we're talking of numbers like 1, because 1 squared is equal to 1. 1 is equal to 1 squared. And then we got what? 2. 2 squared, which will give you 4. So if it's equal to 4 or 1 or 9 or 16 or 25 or 100, etc., we call that a perfect square. So what does this mean if our discriminant is equal to a square? It means that when we simplify this, we're going to get x is equal to minus b plus or minus that particular square that you can have, and let's call that d all over 2a. So here what you will have is our solution. Our roots are going to be what? They're going to be real, unequal, and rational. So here, when our discriminant is greater than 0 but equal to a perfect square, the roots are what? They are unequal, because as you can see here, minus b plus d and minus b minus d are going to give you two different values. Okay, they are unequal, they are rational, they can be written as fractions, because when we simplify the top, we're going to have integers. When we simplify the bottom, we'll have integers. And they are what? They are real. So this is the condition that we have here. if our discriminant is what? Is greater than 0 but equal to perfect square. So the last one that we'll have, the last condition that we have when we look at the nature of the root is when our discriminant is what? Greater than 0, but it is not equal to what? To a square. So it can be any number, but the number must not be what? Equal to square. So what we're going to have, what we will have is our value of x now will only stop when only stop in the sad form. So it can't stop, it can't go further, we can simplify it further. So what do we have here? We're going to have our x is going to be equal to b minus square root of d over 2a, or minus b plus square root of d all over 2a. And what does this mean? This means that our roots are going to be what? Our roots are going to be unequal. And then they're also going to be irrational. We cannot write them as a fraction where both the denominator and the numerator are integers, or they are, they're integers, but we'll have a decimal, because when you simplify the side, it's going to give us a number that has got decimals. So we can't simplify it to be irrational. And then lastly, there will also be real. So this is basically what we'll be talking about when we talk about the nature of the roots. It's important that you watch the next videos where we're going to be working out examples involving those problems. But I just wanted us to understand this so that we do not have any problems as we're going to be solving those numbers that we have. So these are the 4 conditions that we have to emphasize, and it's important that we just take note of those 4 conditions, and it becomes easy for us. So the first one is what? When your root is what? Is unreal. It is unreal because we cannot get the square root of this number that's inside there. So that is when the determinant is negative, or it is less than 0. And then we come to the second condition, when our determinant is equal to 0. That's condition number 2. If it is equal to 0, our roots are equal, they're rational, and they're real. And then if our determinant is greater than 0 but equal to a square, then what you will get is your roots are going to be unequal, your roots will be rational, and that will be real. And then the last one is when our determinant is greater than 0 but not equal to a perfect square, then we're going to get roots that are unequal, that are irrational, and that are real. I hope, this is Mr. Z from Zombe Tutorials. I hope this short video helped you to understand the nature of the roots of a quadratic expression so that you can maximize your performance in the upcoming exam. So please do feel free to share our content, to like our videos, and most of all, to subscribe to the channel so that you do not miss any updates that will be feeding onto the channel. That's all for now. See you in our next video.